Okay, so here we have it. It's Trouble in Paradise running on a Macintosh Plus from 1986. Now it definitely runs a little bit slow because this is a 8 megahertz machine running on a Motorola 6800. So there you go. Running on a Mac Plus. Hello guys. I'd like to show you something I've been working on for a little bit. So one of the things that I collect is I collect classic Macintosh computers. Now in this case I have a Apple Macintosh PowerBook 3 400C, and I also have an Iomega Zip 100 drive connected to it. Now I tend to use the zip drives quite a bit for my classic computers. They're great boot devices for like Macintosh Plus, so I definitely have a lot of those zip disks. Now the thing about zip disks though is that they're prone to a defect known as the click of death. Basically what happens is that over time the read and write heads on the drives get misaligned and they start exhibiting problems with the cartridges, and in the late stage what you end up happening is the drive makes a sound which is known as the click of death. This was actually a common enough problem that a security researcher by the name of Steve Gibson came up with a tool to try to correct and diagnose those problems. The tool was written for Windows, Windows 95 and 98 specifically. It was called Trouble in Paradise, or TIP. Now the tool is pretty fantastic. It basically would scan the disk and it would allow the user to get an early indication of problems with the disks. Now this tool was only available for Windows, and earlier this month I came across a SCSI card for a Windows PC in a surplus place, and after about a week of tinkering I managed to actually get it to work on a Windows machine running Windows 98, but it didn't work great just because the operating system was so old. It had a lot of incompatibilities with the hardware. So so I was able to see the original tool working, but it wasn't an ideal situation. So I thought to myself, I wonder if I could take this tool and make something similar for the Macintosh. I decided to reach out to Steve Gibson, the author of the original tool, to see if I could get any pointers. And he was actually kind enough to send me the original source code for Trouble in Paradise. Now, the original source code was written in assembly language for the Intel x86, which was basically a language I was not familiar with, but with the source code, I mean, over time, looking up materials, I was able to understand it well enough to convert it into a C++ and to write equivalent tool for the Macintosh. Was essentially a port. So I'm going to show you that. So here you are. Here's a tool. I call it the Iomega tester, and we'll just start it up. Now the about screen, I tried to keep it as close as possible to the original. So if you find any like screenshots of the original tool, you will see that it looks a lot similar. I've only made a couple of changes just to make it a little bit smaller so it could work on a Macintosh Plus and fit in the screen. So let's get started over here, and I'll just give you a quick demonstration. I'm going to hit next. Now the tool comes with extensive documentation. Was all something that Steve Gibson had written for his original tool. I managed to preserve everything. There was definitely some difficulties involved in that. I had to find a way to convert the RTF files from the original into something that the Mac could read, and then I had to find out how to display the tool, display the README files within the tool. So it's all here. So I'm going to go ahead and hit OK, and we're going to go to the main interface. So this is the main interface for the tool. There are a couple of things in here, basically saying it's awaiting a cartridge right now. So I'm just going to insert a disk. Okay, so it's going to mount it. Mac OS is going to mount it, and I'm just going to unmount it so the tool can use it. Okay, so now I'm ready to begin a test. So here's a couple features of this tool. It gives you a lot of information about the cartridge. It shows you the spare sectors that are consumed. Basically, in an Iomega cartridge, there's two sides, and each side has a certain number of spare sectors. What happens is that as those sectors are misread, they get mapped onto those spare sectors. Now, one of the primary symptoms of a defective drive is that you end up having a lot of errors, read errors, which cause those sectors to be consumed. Basically, those sectors get remapped onto those spares. In this case here, this is a pretty good indication that this cartridge was used in a drive that was defective, because you have far more spare sectors consumed in side 0 versus side 1. So by giving you all this information, this tool really helps you understand the state your cartridges are in. So I'm going to just start a test over here, and we can see that it's going to start running through a process on the disk. First thing it does is it reads the user data, and then it overwrites it with a pattern. It reads and verifies the pattern, and then it writes the user data back. So it's non-destructive. Basically, it's doing this cycle, so it's basically, even though it's writing to every sector with random data, it's actually doing so in a non-destructive way. And as it runs, it's going to give you a listing of errors. And I'm going to check this box here to turn off the sound so it's not as annoying. So there's 3 classes of errors. There are soft errors. Those are things like parity errors, which are not considered to be serious, just something that might happen, like, for instance, a dropped bit on the bus or whatever. Firm errors is when the drive determines that a sector is likely bad, and it's going to reallocate it into one of the spares. So that's one of the things you're looking for, is firm errors. The last one category is hard errors. So a hard errors means that the drive was not able to recover a sector. Basically, data was lost. So as you run a test on a cartridge, you're basically looking at those errors, and you're trying to come up with an estimate on whether the cartridge is good or bad. And that can also help you determine if a particular drive is bad. And what's kind of neat about this tool is that it has explanations. Once the test is over, it's going to give you an explanation, and it's going to tell you whether the cartridge is good or bad, or whether there's something suspect about your drive. So all in all, this tool is a pretty fantastic tool for diagnosing Iomega zip drives and cartridges. So there you go. You just heard that. That's actually the click, the so-called click of death. So what happened there is it was trying to reread a sector that had problems. You can see that there's a cartridge already has 2 firm errors. So definitely a cartridge that is not all that great. Now, once this completes, I'm going to be able to click and explain. It's going to tell me exactly what it found and give me recommendations. So overall, this is a pretty fantastic tool, and I'm very grateful to Steve Gibson for giving me the source code and allowing me to create this Macintosh port. It's now on GitHub, and it's available for anyone that has a Macintosh from this era. It does require a SCSI port, so basically we'll work on the Macintosh Plus through the PowerBook, or the Power Mac G3, I think it is. Those are machines released from 1986 through 1997. So basically anything in that era. So yeah, so there you go. That is Trouble in Paradise. You can see how we found our first hard error, our second one as well. Things are not looking good for this cartridge. Yeah, so I'm going to stop the video right now. Hopefully this gives you a pretty good idea of this tool. And I'll have links in the description so you can check it out for yourself.